Hello everyone, this is Suprit. I'm pursuing my engineering in information science branch of Sri Venkateswara College of Engineering. The first topic is Linux history. Linux was created by Linus Torvalds in 1991. It, it started as a hobby project to create a free and open source operating system. Linux quickly gained popularity and became the foundation for various distributions. Early in its development, the Linux source code was made available free on the internet. As a result, Linux history has been one of the collaboration made by many users from all around the world, corresponding almost exclusively over the internet. In its earlier days, Linux development revolved largely around the central operating system, the kernel core privileged executive that manages all system resources and that interacts directly with the computer hardware. We need much more than this kernel to produce a full operating system. Of course, it is useful to make the distinction between the Linux kernel and a Linux system. Linux kernel is an entirely original piece of software developed from scratch by the Linux community. The Linux system as we know it today includes a magnitude of components, some written from scratch, others borrowed from other development projects, and still others created in collaboration with other teams. The components of Linux system are: the Linux system is composed of three main bodies of code in line with the most traditional Unix implements. There are three components of Linux system. First one is kernel, second one is system libraries, third one is system utilities, and the first one is kernel. The kernel is responsible for maintaining all the important abstractions of the operating systems, including such things via virtual memory and processors. And the second one is system libraries. The system libraries define a standard set of functions through which applications can interact with the kernel. These functions implement much of the operating system functionally that does not need the full privileges of kernel code. System utilities. The system utilities are programs that perform individual specialized management tasks. Some system utilities may be invoked just once to initialize and configure some aspects of the system. Others, known as daemons in Unix terminology, may run permanently, handling such tasks as responding to incoming network call action, acceptance logon requests from terminals, and updating log files. Now coming to the design principle in operating systems. First one is modularity. The operating system should be built in a modular manner, allowing for easy addition or removal of components. And the second one is portability. Operating systems should be able to run on different hardware platforms without major modifications. And the efficiency. Operating systems should utilize resources efficiently or effectively to provide optimal performance. Reliability. Operating systems should be stable and able to handle errors without crashing. And we coming to security, operating systems should provide mechanisms to protect data and prevent unauthorized access. And scalability. Operating systems should be able to handle increased workloads without significant degradation in performance. Now coming to the Linux design principles. Linux is a multi-user and multitasking system with a full set of Unix compatible tools. Its file system adheres to traditional Unix semantics and it fully implements the standard unique networking model. Main design goals are speed, efficiency, and standardization. Unix is designed to be compliant with the relevant POSIX documents. At least two Linux distributions have achieved officially POSIX certification. The Linux programming interface adheres to the SVR4 Unix semantics rather than to BSD behavior. The open source of the design principle are Linux follows the principle of free and open source software, allowing users to access and modify the source code. POSIX compatibility. Linux adheres to POSIX standard, ensuring compatibility with other Unix-like systems. Kernel modularity. Linux kernel is designed to be modular, allowing for easy addition or removal of features. Now coming to the design principles of device independence. Linux treats all devices as files, providing a uniform interface for accessing hardware. And the process management. Linux effectively manages processes, allowing for multitasking and resource allocation. And the networking support. Linux provides robust networking capabilities, supporting various protocols and services. And in kernel, Linux kernel development follows a distributed model with thousands of developers contributing to its continuous improvement. Development is guided by Linus Torvalds and a core team of maintainers who oversee the integration of changes. Each release goes through rigorous testing and review before being made publicly available. Many other standards exist in the Unix world, but full certification of Linux against them is sometimes slowed because they are often available only for a fee, and the expense involved in the certifying and operating systems compliance with the most standards is substantial. However, supporting a wide base of application is important for any operating system. So implementation of standards is a major goal for Linux development. Even if the implementation is not formally certified, in addition to the basic POSIX standard, Linux currently supports the POSIX threaded extensions, pthreads, and a subset of POSIX extension for a real-time process control. And finally, the milestones in Linux history. In 1994, the first stable release of Linux version 1.0 was made available. The Linux community formed the Linux International Organization in 1996 to promote and support Linux worldwide. In 2001, the IBM announced its support for Linux, marking a significant milestone in its acceptance in the enterprise world. In 2005, the Linux kernel reached version 2.6, introducing numerous improvements and new features, and the Android, a popular mobile operating system based on the Linux kernel, was released in 2008. In 2015, Microsoft announced its support for running Linux on its Azure cloud platform. And finally, the conclusion for Linux history and design principles is as follows. Linux has revolutionized the operating system landscape with its open source philosophy and design principles. Its continuous development and widespread adoption have made it a key player in various domains, from services to embedded systems. Linux' rich history and design principles continues to shape the revolution of operating systems. Linux takes a lot of practice, but overall it is a good operating system, very secure, customizable, and it is open source. Windows is good for everything, but Linux is best as server operating system. Thank you.